12.5, number 1, I am supposed to find parametric equations for a line that passes through 3, negative 4, 1 and parallel to 1, 1, 1. So I'm going to describe that line, first of all, as the range of a function, which I'll call R, with a harpoon above it because it's vector valued, that takes in real numbers and gives out ordered triples of numbers, of real numbers. So that is to say, for each input, there is a vector output. And here's the explicit description of that rule of correspondence. R assigns to t the vector 1, 1, 1 times t plus 3, negative 4, 1 for any number t in the real numbers. Okay. So that was setting up a function, vector valued function of one real variable. And that is not the parametric equations. That is a parametric equation. It is sort of three equations in one, if you will. The parametric equations with a plural s would be a component-wise description of this, describing the first component, which we could call x as a function of t, and y as a function of t, and z as a function of t. That's what the textbook's looking for here. And those three equations together describe a line. I wanted to make a note to go along with my drawing down here. So far, all I've done is drawn the point 3, negative 4, 1. That's this guy. 3, negative 4, 1. This point. And then I drew the vector 1, 1, 1 emanating from the origin over here. I'm going to put a copy of him with his tail over here at 3, 4, 1. So if I pick that up and have a point in just the same direction, it would look about like that. Ooh, a little bit long. Okay, so that's another copy of 1, 1, 1. And then the line that we are describing, I'll make that in blue, though I know that blue doesn't show up very well, is the line that goes in the direction of 1, 1, 1 forever, starting at the point 3, negative 4, 1, and goes in the opposite direction. When t is negative, we take negative multiples of 1, 1, 1. And so you should think of this as starting at 3, negative 4, 1, and moving either in the direction of 1, 1, 1 from there, or in the opposite direction. So that's the blue line. And that, again, that blue line is the range of this function I've defined up here, r. R vector, you might call it, since it carries a harpoon above it. So the note that I want to make is this same line is the range of lots of functions. Now let me give you an example. Okay, the function that uses also 1, 1, 1, and 3, negative 4, 1. But instead of t, you put in, say, 2 times t, right here. Okay, so let's think about this function right here. I didn't call it r of t, but maybe to give it a name, I'll call it r sub example t. Okay, so this example r here is different. You notice that it is genuinely different than this r up here, the different function. Nevertheless, the range of the two things is the same. Imagine this, when t is 0, you start at 3, negative 4, 1 right there. And then as t increases, you move in the direction of 1, 1, 1, but you move twice as fast as regular r does. Our example here would simply move in the direction of this red arrow twice as fast, and would move in the negative direction for negative values of t twice as fast. So there are many, not just these two, but there are many different vector-valued functions of one real variable that have the same range. That is to say, there's many ways to parameterize a line, and this answer that I wrote right here, right, this response, is not the only possibility. Also, from this parametric equation, I could write a system of three parametric equations that would also describe the line.